So we were able to create structures through 3D printing and computer-aided design, where we were able to see fibrin grow and have cells and fibrin be sustainably working and functioning on these structures. And the first models that you see on the left here are the first generation designs that we built, but as we tried to view the strands, the problem that we encountered was that we couldn't see the fibrin working through the inverted microscope, so we concluded that we needed a hole through the bottom. And this unit here was built to define the maximum height our substrate could be before the inverted microscope could no longer focus on the post as well as see the fibrin at work. And these models that you see in the middle here are our second generation, with the new cutout center. And it made viewing the strand from below on the inverted microscope possible. And the figure that you see on the right was our third generation design with leaning posts. They leaned inward, so that made visualizing the strand on the microscope much easier than the previous vertical posts, as you can see here.
So the way we actually strung our strands on the vertical post was we began by taking out the posts that were on the disc out of a sterile tube, placing them on a petri dish. The petri dish had a puddle of fibrinogen, and we infused it with cells because we were able to see that the cell infused actually had cells in the strand versus when we didn't infuse them, and it was just a regular strand with 1 or 2 cells. So we placed them upside down with the post facing down in the puddle, and then we were able to pipette thrombin in between the posts. We waited about 60 seconds before we lifted. If we left them down for too long, then it would form about a mesh or a net in between each one, and we weren't able to string it. So we waited almost around 60 seconds before we were able to flip it over, and then when we started manipulating between the posts, and we were able to do different structures such as a triangle or just single strand or 2 strands coming out of 1 post, and that is how we did the cell-infused strands. Here's a picture of the different strands. This one has 2 strands. This one has, it has 1 strand in 2 posts. This one has 3 posts with strands in between, and this one's the 4. This one's more of a net or mesh of cells, and this is, as you can see, like a more singular. However, they're all cell-infused. Our future direction is to 3D print heart. This is regenerative medicine and personalized medicine. The way we plan to do this is we start at the micro level by actually differentiating iPS cells into cardiac cells. And then we went to macro structures where we actually form strands. And we can maybe in the future form more strands, maybe form a muscle. And then, of course, personalized medicine would be our future goal.
Thank you.
Thank you.
Thank you.
Cool.